Hey guys, Mrs. Stanton here, coming back to you live from Penn High School, room 231. All right, topic 10, student activity sheet 4, systems of inequalities. Guys, this is the same thing we were doing, but instead of an equal sign, we're going to have symbols like this or this or this or this. Okay, I guess that's already what I wrote. So we're going to have to think about some different situations here. We're going to use Desmond again since we've been with his lawn mowing business now for a while. Okay, so Desmond needs to schedule his lawn mowing jobs each week. So he and Shelly, I don't know if girlfriend, friend, wife, whatever, they have to do mowing and edging. So there's some things we need to consider. Okay, we need to know how much time they have available to themselves, the cost of gas and other expenses, how much to charge, how to get their customers, location, how long it takes to do each yard. Okay, based on our previous experiences, Desmond and Shelly came up with some time estimates. Okay, their standard size lots, it's going to take them 1 hour to mow, a half hour to edge. Large corner lots take 2 hours to mow and 45 minutes to edge. So Desmond, looks like Desmond's going to take care of the mowing. Desmond can spend at most, that's where our inequality symbol comes in, 30 hours each week mowing lots. Shelly can spend at most 12 hours per week edging. Okay, take note, Desmond's going to take care of the mowing. So Desmond's going to look at those two situations. And then Shelly is going to take care of the edging. So Shelly's going to look at the half hour to edge and 45 minutes to edge. Okay, so let's just talk about Desmond for a second. Okay, what is the number of lots? X and Y. There's no constraints here. Constraints means limits. Okay, how long is it going to take him to mow each lot? Well, it takes him 1 hour to do a standard lot and 2 hours to do a corner lot. Constraint, it says that he can spend at most 30 hours, meaning that's the biggest the number can be. Okay, now the edging. So now we're going to look at Shelly. Okay, we know for a standard lot, it takes her half 30 minutes. So I'm going to write that as half. 30 out of 60 gives me 1/2. And then a large lot, 45 minutes. Well, that's 3/4 of an hour. And her constraint is she doesn't have more than 12 hours to spend on this. Okay, so my system, we're going to say for Desmond, 1x plus 2y is less than or equal to 30, meaning he can spend 30 hours, he can spend 29, he can spend 10, but he cannot spend a second more doing that. Okay, our second equation is Shelly. Half an hour per standard plus 3/4 of an hour for a large is less than or equal to 12. That's our second constraint. So let's go on. Okay, question 3. Okay, they want us to, I went ahead and I wrote this. I also changed these to decimals because I feel like you guys might be a little bit better with that. So we have to look at these different combinations and what may or may not work. The first option, what if we mowed 10 standard size lots, that's our X's, and 8 corner lots, large corner lots. Okay, those are our Y's. So what I did was I plugged these into each situation. Let's just do Desmond's first. I said 10 standard lots plus 2 times 8, that's my 2 times Y, has to be less than or equal to 30. So 10 plus 16 less than 30. 26 is less than or equal to 30. Yes, that's true. Come over here. Half of 10 is 5. 3/4 of 8 is 6. Is that less than or equal to 12? 11 is less than or equal to 12. Yes. Okay. Both of those are satisfied. Desmond could spend 26 hours mowing and Shelly could spend 11 hours edging. Now let's do the same thing for 6 standard lots and 11 corner lots. Plug those in and 36 is less than or equal to 30. No, that is not true. Okay, so that would not work for Desmond. He could not do 6 standard and 15 large. Shelly would get 14 and a quarter, 14.25 hours. No, that's not less than or equal to 12. Okay, so neither of those are satisfied. It would take Desmond 36 hours and Shelly 14.25 hours. That goes over both their time limits. Now, if we did 6 standard and 12 corner, plug those points in. 30 is less than or equal to 30. That's true. 12 is less than or equal to 12. That's true. Both are satisfied. It would take all the time that both Desmond and Shelly have available. And then the last one, 18 standard and 6 corner. Okay, if we did 18 standard and 6 corner, I get that 30 is less than or equal to 30, which is true. So Desmond's okay here. But if I plug this into Shelly, it would take her 13 and a half hours. 13 and a half is not less than 12. Okay, so Desmond's is satisfied with exactly 30 hours, but Shelly's is not. She would go over her available time by 1.5 hours. Okay, so now let's put these on a graph. Okay, so my first equation here is sketch the graph. So guys, I graph it as normal. I did my intercepts. X is 30, Y is 15. Okay, and I put those both on there. Now, to show that we have to spend less time under that time, we're going to do what we call the shading. We're going to shade down. Okay, sketch the second graph. Okay, if I find my intercepts here, I get that X is 24 and Y is 16. So that's what Shelly's graph would look like. And here we're going to combine both of those together. Now, when we combine both of these inequalities together, the part that holds true is where the shading overlaps. So you can see I have my pink. The pink is a little bit bigger than the blue line here. And over here, the blue line's a little bit bigger than the pink. I only shaded in that green where the blue shading and the pink shading overlapped. Okay, so Desmond made some observations. Neither variable can be negative. Think about that. We can't mow negative lots, guys. We can't mow negative lots. We can't work negative hours. So we have to come up with some additional constraints. We said the original constraint had to be less than or equal to 30 and less than or equal to 12. Well, again, we can't mow negative. So we're going to say X is greater than or equal to 0 and Y is greater than or equal to 0. Guys, we call these the common sense constraints. Common sense constraints. Meaning we don't really need to say it, but we're going to say it. So now they continued. They also noted that the point 10.8 is below both of the lines. Okay, that agrees with an observation we made earlier. Can we explain what Desmond means by this? When we check the point 10.8 on the graph, it falls below both their lines, making it true. And I'll just go back and show you. Okay, point 10.8 is right here. Okay, that falls in both the pink and blue shading, so it holds true. Okay, so now I've got these graphs again here. Okay, we've got these graphs. They want us to fill in this information. They want to know the point 615. So here's the point 615 falls where? Well, here's my two lines. So I'm going to say it falls above both lines. This corresponds to neither Desmond nor Shelly's graph. Okay. It's not true of Desmond's line and it's not true of Shelly's line. It's an outlier. Okay. Meaning they're not going to have enough time. Neither of them have enough time to do that one. Okay. So now the point 612. Okay, 612 falls on. It falls on both of those lines. This corresponds to both Desmond and Shelly having exactly the time required. The point 18.6, well, it falls on Desmond's line. And it falls above the line 1/2. So here's pink, the point 18.6. It falls on Desmond's line, but it falls above Shelly's line. This corresponds to Desmond having exactly the time required to mow, but Shelly having less time than required for her in her schedule. Okay. So then lastly, Desmond and Shelly decide to allocate more time per week. Desmond increases his maximum hours to 30. Shelly increases hers to 15. So the only thing that's changing here, guys, is instead of 30, it's 36, and instead of 12, it's now 15. Same equations. And then we have our common sense restrictions, which all this does, guys, is limits us to the first quadrant. Okay, all positive numbers. So I went ahead and I graphed these two lines. I put Desmond in pink, and I put Shelly in orange, and then I shaded. Okay, shaded each of those, and where my pink and my orange shading overlapped, I colored it in here. Okay, so they want to know, are the mowing schedules represented at the points 6:15 and 18:06 feasible now? Okay, so I went ahead and I graphed those. I've got the intersection at 12:12. The point 6:15 falls below the orange line and on the pink line, so that one's good. And then the point 18.6 falls well within the shaded region of both. They are both feasible. Okay, you can go ahead and work on those problems with your teacher. Have a good day. Bye.